Hello, my name is Curtis Naibo. I am a Master's of Science in Quantitative Finance student, currently completing my dissertation research through the University of London. In this video, I would like to share with you my experience studying quantitative finance and working on related projects and work. Hopefully it will help you decide whether graduate level academics is the right choice for you and identify some of the opportunities that may be available to you afterwards. We'll split this video up into a few parts. First, I'll share my background and why I chose this subject. Then we'll talk about my thoughts on the future of the financial industry. I'll discuss some crucial topics and skills that you should pay special attention to stand out in the industry. Then I'll talk a little bit of why I chose a postgraduate degree and why it was a good fit for me and why it might be a good fit for you too. And then I'll provide some details about how that all kind of comes together into one original piece of research, which is your dissertation. I'll talk about my topic and my research that I'm completing right now. And finally, I'll provide a little bit more advice to those thinking about taking a similar path to study quantitative finance or any quantitative subject for that matter. So starting with a little bit about my background and my work experience. My background is, of course, in finance, where I decided to pursue a finance degree as I was generally interested in investing and the stock market overall. I then started my undergraduate finance degree at a university here in Canada. In that time, I also took programming courses to be able to program in R, as well as a few other computer science courses. I've always been a bit of a techie person, and I did a lot of web design and some programming in the past, and so I wanted to keep those skills sharp as while I study finance and economics. I actually didn't have much of a math background at that point, but once I got into my higher level courses and found the applications of maths to economics, game theory, finance, and computer science, it started to come a lot more naturally to me. So once I completed my degree, I moved to Calgary, Alberta, which is a bit of a hub in Western Canada. I worked for a large tech consulting company where I initially worked in strategic planning, and that role focused on business plan development for the Western Canadian business unit, as well as I was the primary contact for market intelligence and that type of analysis. I then moved from that role to a senior consultant role on our emerging technologies team, where we focus on providing a wide array of new technologies for our clients, but I mainly try to focus on data science and analytics with a little bit of automation. I really enjoy this work and consulting as it has a strong focus on education and academics in order to keep up with the changing pace of technology. And we also are able to work in all kinds of industries where I can apply my expertise and my skills, such as anything from fintech and banking to oil and gas to government. So that's enough about me. Let's talk about where the future of the financial industry is heading. So I think it goes without saying that technology is the future driver of the financial industry. I've been fortunate through my work as a consultant in the technology industry. I've been able to see a lot of these changes firsthand, and I've been able to work and see them in multiple sectors from not just strictly finance and banking, but also risk management and trading in other areas such as commodities or oil and gas or natural resources, that sort of thing. And we've already seen developments in finance take place that in the last 5 to 10 years that wouldn't have even been possible 15 to 20 years ago. So as an example, we're starting to see wealth management companies come about that have very little human intervention and run on almost completely automated models. And these are positioning themselves to be able to replace in-person financial advisors. And one of the biggest obstacles to this wasn't even the necessary improvements in technologies to be able to deliver this type of service, but more a shift in public trust, where people are now starting to become really comfortable with the idea of having an algorithm manage their money rather than having someone that they could actually talk to and interact with. And of course, there's also the examples of cryptocurrencies and the blockchain platforms being utilized by firms to enhance security while at the same time decreasing transaction clearing times and other benefits. So I think the future of the financial industry will be driven in large part by advancements in machine learning and AI. The applications of this touch all areas of finance, from computer-driven financial advisors like the example we just talked about, or to risk management, to trading, to regulatory compliance, and more. All areas from back office to front office, buy side and sell side, are starting to implement data science techniques and more advanced statistical techniques as computer power has become more available. And a lot of these algorithms and big data models that were first thought of and initially developed back in the 80s and 90s are finally starting to see their day, as there is the massive amounts of computing power with the proliferation of cloud providers and cheaper hardware. And this has led to a boom in data science, and the markets seem to be a perfect testing ground for many of these models as it provides continual time series data with countless factors to be able to work with. And this has led to firms being able to feed huge volumes of data through hundreds of factors to reach actionable outcomes on those theoretical models that were developed years ago. That includes which stocks to buy, which commodities to sell, which derivatives are priced accurately, and which derivatives provide the best hedge for a given set of conditions. And we're also starting to see bigger things like central banks are starting to use more complex real-time data-driven models, or funds managing portfolio allocations based on programmed mathematical models. And of course, the trading firms not only use data science methods to find trading signals, but also incorporate new data sources like satellite imagery of crop yields in order to forecast commodity yields, for example. So it's no coincidence to see that the top performing hedge funds like Bridgewater Associates or Renaissance Technologies rely almost solely on quantitative strategies. And with the adoption of these types of technologies, we're not only seeing it in direct banking or trading capacities, but we're also seeing it in government and auditing firms. They're starting to adopt more machine learning models to identify fraud and to stop crime such as money laundering and more. So in short, I see the proliferation of data science methods applied to the finance industry to continue to drive change and create new opportunities and even new markets. With that being said, machine learning and AI is also quite overhyped. A lot of these models have been in use and have been developed for many, many years and are only now getting recognized. And there will always be a human element to most areas of finance and the finance industry as a whole. But the competitive edge in finance has shifted to those firms that utilize and really understand these technologies, and having a fundamental understanding of how these underlying technologies work is becoming a requirement to really succeed in the industry. So moving on to a few topics that I think you should really pay some special attention to in order to really stand out in the financial industry. And before we get into it, the topics that you should really pay attention to first and foremost are those topics that you're most interested in, despite what everyone else says. The goal is to find something that you're passionate about, as that will help you succeed. However, with that being said, if you're open to learning new skills or would like a better idea or some guidance on what specific subjects will help you most in the finance industry, there are two topics that I think you should spend a little bit more focus on in addition to your main studies. So this kind of echoes our last discussion where we talked about the future of the finance industry. And so with that, the top skills that I think one should pay special attention to would be mathematics and programming. Starting with math, to be more specific, I'm talking about applied mathematics rather than pure maths. I'm mainly referring to subjects like calculus and linear algebra, as these will then give you a solid foundation to understand statistics and be able to apply that to financial data, which is nearly a requirement to work anywhere in the finance industry. Now, the level of understanding in mathematics you'll need depends on the path you choose. Many of the roles in the finance industry require a very minimal or very basic knowledge of statistics and math. However, in any quantitative discipline, you'll require a solid foundation and understanding of these subjects. By studying these topics early, it'll really allow you to understand the mathematical concepts that you'll encounter in your higher level economics and finance classes, specifically classes like portfolio theory and econometrics. And it'll also allow you to branch out into more complex topics like machine learning and AI. So ideally, you've began improving your calculus, linear algebra, and statistics skills alongside your finance and economics classes. And so this is where the second topic that I think you should really focus on comes into play, which is learning to code. Learning to code in a programming language is a must in any quantitative discipline. However, it will also help in nearly any job you encounter in the financial field. Spreadsheets are very useful tools. However, they fall short when working with large amounts of data, developing custom algorithms, or programming complex trading models. Learning to code will allow you to take the models you learned in class and apply them to limitless data sets on your own, such as the minute data of all New York Stock Exchange stocks, for example. The application of these concepts that you learn in class can then be expanded into machine learning algorithms and artificial intelligence applications and other types of further research. So this is crucial to being able to contribute to any quantitative field. Like as we talked about earlier, where machine learning and computational finance is only going to play a larger role in the future of the finance industry. Looking at the most common programming languages for finance and data science, which are R, Python, Java, and C#, I would suggest learning R or Python, as they have kind of taken over and become the go-to programming languages for both finance, statistics, and as well as data science overall. They're both free and open source, and they both have amazing ecosystems of packages and libraries that cover a wide array of topics from data science, finance, machine learning, math, even stock trading algorithm development. My preference is Python. I've been using that for several years, both in academics and in my job on client projects. However, I have used R, and R is also used extensively in academics as well as within companies in the industry. Both Python and R make it really easy to create professional reports and academic papers using R Markdown in R or Jupyter Notebooks in Python. Although R has a pretty streamlined way to be able to turn your data science projects into web applications that can be viewed through a browser using the Shiny Apps package. So either way, in my opinion, you can't go wrong learning R or Python, as they're both very in-demand skills in the job market, and the learning curve isn't quite as steep as some other programming languages. So where do you start learning to code? There's a huge amount of online courses and information available on the web for both programming languages, as well as likely a bunch of university courses that you could also take where you go to school. Websites like Coursera.org host complete free classes from world-renowned universities, and they cover a wide range of subjects. And this is a great place to get started in either R or Python, or to delve into more advanced topics with courses such as mathematics for machine learning, deep learning, machine learning for finance, and many more. So in summary, having a good foundation in math gives you a good understanding of how financial, statistical, and machine learning models really work. And learning to code really opens the door to allowing you to apply that knowledge through research or on the job. Now that we've talked about the subjects that I think are really important to study and that you should pay a little bit of special attention to, I'd like to talk about why I chose a postgraduate degree in quantitative finance and why a postgraduate degree may be a good choice for you too. I decided to study a postgraduate degree as I saw it as the most effective way to enhance my career prospects. I realized while I was working through my undergrad how much I enjoyed statistics, portfolio theory, derivatives, and developing programs and algorithms to be able to solve these types of problems in these subjects. This led me to choose to study a Master's of Science in Quantitative Finance. I chose a Master's of Science specifically as they are generally more technical than an MBA degree, and they allow you to dig deeper into a more specialized topic, culminating in the completion of a dissertation where you contribute to the existing literature on a topic by providing your own original research. Through choosing quantitative finance, I'm able to focus solely on studying the topics that interest me the most, such as econometrics, derivatives, and game theory. The knowledge I gain from studying these classes applies to many other fields like machine learning and AI, so it kind of allows everything to come full circle for me. So what I learned in the Masters of Science program is very transferable to not only finance-related work, but to many different roles in data science within different industries as well. I have also found that having a postgraduate degree in this field helps validate that you in fact have the skills you say you do when it comes down to that subject. Since the words quant and data science have become buzzwords and are thrown around very loosely these days, a postgraduate degree in the subject gives you that additional credibility that you indeed have those skills and you have studied that subject extensively. But a postgraduate degree not only gives you more in terms of career options, but it also opens the doors to further education. If I choose, I could continue within academics and pursue further education like a PhD, where I could continue to contribute within the subject by providing more focused research and building off of what I've learned and the knowledge I've acquired through my master's program. So is a postgraduate degree right for you? It all depends on your goals and where you would like to be in the future. If you would like to signal to future employers that you are passionate and knowledgeable on a specialized topic, or you would like to become an expert in a field and pursue further academic research or further education like a PhD, then a postgraduate degree may be the right choice for you. It is important to note that, like we talked about in the last section, at this time we have more options for education than ever before. You have the option to complete a postgraduate degree in person or online, as well as there are part-time or full-time programs. I chose to complete my Master's of Science through the University of London in the UK. It was all online as I am based in Canada, and I was able to continue working in the industry while completing the degree. And this was very beneficial for me as I could immediately apply the concepts that I learned in class to client work as I learned them. Since it was a very technical program with a lot of theory and a lot of math, it was very well suited for distance learning. And the University of London provides awesome mediums to be able to collaborate and interact with other students. And I was also able to write my final exams here in Canada at the University of Calgary, where I live. So if you're thinking along the same lines as I was when I chose to begin my postgraduate degree, I would suggest taking some time to research some of the options and the universities that are a best fit for you and the topic that you would like to study. Now I'd like to take some time to provide some detail around my master's degree dissertation and the topic I chose, as it kind of incorporates all the advice that I've given in this video. So we've talked about the future of the finance industry and some of the topics or subjects that I suggest that you focus on, like statistics and coding. We've discussed why I chose to pursue a postgraduate degree and why it might be a good choice for you. So now I can give a bit of an example of how this all kind of comes together and can be applied to a final piece of research by giving some insight into the dissertation process as well as the topic that I chose. I chose to complete a dissertation or thesis as part of my master's program because it would help open doors for me to pursue further research as part of a PhD or an industry in a research-focused job. Having some novel academic research that you've completed in your portfolio is very helpful in that regard. And the alternative to this path would be to complete your master's through a course-based route, which has its own pros and cons, and may be worth thinking about if your ideal path sounds similar but a little bit different than what we've been talking about. So for my thesis topic, I spent a lot of time reading and looking for a topic that allowed me to implement the things I learned within my master's classes, more specifically my econometrics classes, as I found them the most interesting, and combine that with my existing knowledge around machine learning and coding. This led me to my dissertation topic, where I will be studying the ability of neural networks to predict stock sector volatility, and I'll be comparing their performance to the standard volatility prediction models, which are the GARCH or ARCH models, most often used in the industry today. In recent years, neural networks have been explored for their wide array of applications due to the high flexibility and their power to map complex nonlinear functions. So they have been proven effective in forecasting, classification, pattern recognition, that sort of thing. And there has been studies in the past where neural networks have been implemented to predict volatility using the industry standard GARCH model as a benchmark to beat in terms of performance. However, the results have been mixed, with neither a clear winner or loser overall between the neural networks and GARCH models. So my research will help break this down a little bit further to see if there's specific volatility profiles where one model may outperform the other, as opposed to applying both models to just a stock index. The volatility profiles will be in the form of a high, medium, or low volatility sector. This dissertation topic will allow me to contribute to the existing literature by testing if comparative neural network and GARCH volatility prediction performance is affected by specific volatility profiles or the specific industry sector to which it is applied. Overall, the challenge with predicting volatility is that time series volatility data has specific statistical properties that violate the assumptions of common models like linear regression. And accurate volatility prediction has a wide range of applications and is very important in finance and economics. Anything from risk management and derivatives pricing to trading algorithms and portfolio asset allocations, they all rely on accurate volatility predictions. So I'm very excited to study this topic. So now we've come to the last topic, which is just a little bit more advice for those thinking about pursuing a postgraduate degree. A lot of this advice will echo what we've already talked about and what I've already said, but one of the biggest things I can say is to make sure that you take your time to explore your options. And this includes your career options as well as your academic options. In academics, I find that it's extremely important to find something that you're passionate about. I know it sounds cliche, but you'll need to be in it 100% in order to succeed. And if you really enjoy what you're doing, it just makes it that much easier. Another piece of advice I would give is to consider the method of education. While both in-person or online postgraduate degree programs are available, they each have their pros and cons, and it just provides more options for you to explore. They differ in terms of experience required, they differ in terms of price, but the overall education quality between the two remains quite consistent no matter which method you choose. However, it's always helpful to reach out to students who on forums or anyone you know that has attended the master's programs that you may be thinking, and hear their thoughts on it and hear the pros and cons from someone who's gone through the program. Lastly, I would encourage you to get involved in your undergrad years at your school through events and student societies. Get to know your professors, get to know your peers. These connections will be very valuable to you when not only applying to future master's or PhD programs, if that's the path you choose, but also when you join the workforce and start your career in the industry. So this brings us to the end of my video. Thank you for watching. I hope this gave you a bit of clarity around whether a postgraduate degree may be the right path for you. And feel free to reach out to me via LinkedIn or email, and I'll be happy to provide any other advice I can or any other perspectives on certain parts of the program that you would like to hear from. So thank you.